I'm going to do example number 17 again to show you that you can eliminate the x variable and get the exact same answer. So this time I'm going to focus my attention on the x's, and I'm going to eliminate it by multiplying by a -2. You see, what you really are doing is you're saying, okay, look at my numeric coefficients and find out what their LCD is. And whatever their LCD is, then I need to make both of them be that LCD. Well, 4 is already the LCD, so what do I have to multiply by 2 to get the LCD? And then not only do I want them to be that number, I want them to be opposites. So this one's positive, I'm going to make this one negative. So I'm going to copy down the first equation, which I did not change at all. 4x plus y is equal to 1. And then I'm multiplying this one all the way through. So I'm going to have a -4x, and then I'm going to have a -10y, and then I'm going to have a -2 on the right hand side of the equal sign. Now I'll add these together. So 4x and -4x is 0. That's what I wanted to happen. Y and -y, 10y is -9y. And a +1 and a -2 is a -1. So now multiplying by the reciprocal of the -9 here, I'm going to get that y is equal to +1/9. And now, like before, I'm going to choose one of the equations for that 1/9 to go back into. And I'm going to go ahead and I'm going to choose, I think I'm still going to choose the first equation to put it back into. So I have 4x, and then plus, and then 1/9 is my y value, and that equals 1. And I'm going to just go ahead and change 1 to 9/9. Remember, any number over itself is always 9, or is always 1. So 9 over 9, 9 is my denominator in that fraction, so that's what I need it to be, 9/9. And now I have that 4x is equal to 9/9 minus 1/9, which is 8/9. And then I'm going to multiply by the reciprocal in the next one, so that I can get the final answer for x. And then I see fractions, right? So I'm going to do some canceling. So 1 here and 2 here. And so now I see that x is equal to 2/9. And you see, I got the exact same answer as before. X is 2/9 and y is 1/9. So it doesn't matter which variable you choose to eliminate first, you can still come up with the same answer. The choice will be yours. Now continuing on, let's take a look at our next example. Our next example, the problem starts a little earlier. The problem starts here with not both equations being in the same form. So the first thing is I want them in the same form. My preference is actually standard form. I find students have a lot less trouble solving systems using the elimination method if you put them both in standard form. So I'm going to move the 11y over to the right hand side by adding its opposite. So I'm going to have 8x plus 11y is equal to a -16. And then I'm pairing that with 2x plus 3y is equal to -4. Now from there, what I have to do is I have to decide on a variable to eliminate. So I can eliminate x or I can eliminate y. I think I'm going to work on x. So I need these things to be both 8s, right? So to get this one to be 8, I'm going to multiply by a 4. But I want them to be opposites, so when I add them, they go away. So I'm going to multiply by a -4. So in my second step here, I'm going to have 8x plus 11y copied down and equals -16. And then I'm going to multiply through. So I have a -8x, and then plus a -12y, and then that's equal to a +16. And then I'm going to add them together. So 8x and -8x is 0, and 11 and -12y is -y, and that's equal to 0, which means that y is equal to 0. And that was my third step. Now in the next video, in the next video I will finish it up by solving using one of those equations to get what x is equal to.